This lesson is called heavy or massive, and basically it's the difference between weight and mass. So by the end of this lesson you should be able to correctly identify the units that we use for mass and weight, be able to explain the difference between mass and weight, and also understand how a gravitational field will affect that weight. So before we start, just have a think about this sentence and think about what's wrong with this sentence. I weigh 62 kilograms. So apart from the obvious, which I'd love to have a little less mass than that, the reason that this is wrong is because weight is actually a force and therefore measured in newtons, and actually 62 kilograms, that unit refers to my mass. So mass can be described as how much matter an object has, so how much stuff there is, how many particles are in that particular material, and it's measured in kilograms. So that's really important. So when you see kilograms, that you're looking for the mass. That's the mass, not the weight. And mass will stay the same no matter where you go throughout the universe. Weight is actually a force, and it's the force on an object due to gravity. And it's measured in newtons, as all forces are measured in newtons. And it changes depending on the gravitational field. Now here on Earth, we take the gravitational field strength to be 10 newtons per kilogram. But on the moon, that gravitational field strength is a lot weaker. So have a little pause and think about, where would the flag be lighter, on the moon or on the Earth? And hopefully you realised that the flag is going to be lighter on the moon, so because the force of gravity is less, although the mass of the flag would not have changed. So mass and weight are related, and they're related through this equation. So weight in newtons equals mass in kilograms times gravity in newtons per kilogram. And on Earth we take gravity as being 10 newtons per kilogram. So you need to pause the video now and make sure that you've got that equation written down. So again, the best way to practice these is to have a go at a few questions. So this is a couple of example questions. Pause the video now, have a little go at the questions, and then I'll come back and show you the answers. So the first question was to calculate the weight of any mass that's on Earth, and to do that all you do is times that by 10. So 7 kilograms times 10 would give us 70 newtons, 0.5 times 10 is 5 newtons, and the third one is the one to be very careful with. What they've done, and they do this in exam questions, is give you 400 grams. You need to convert the unit to kilograms first before you times by 10. So the first thing you would do is 400 grams divided by 1,000 would give you the kilograms, and then times that by 10. And that would give you 4 newtons. Now the second equation was to actually reverse the equation, to rearrange the equation. So if we've already been given the force, we know that the gravitational field strength is 10. So all we need to do is rearrange that equation, and that would give us force divided by gravity, which means the mass of the steel block would be 5 kilograms. The next part of the question takes the mass as 5 kilograms and then puts it onto Mars. And on Mars, its force would be 18.5 newtons. And so here we're asked to rearrange again to calculate field strength. So all we do is the force equals 5 kilograms times gravitational field strength, which means the gravitational field strength will be the force divided by the mass, which gives us 3.7 newtons per kilogram. So hopefully you'll now be able to identify the units for mass and weight. You'll be able to explain the difference between the two, and also be able to calculate and understand how weight is affected by the gravitational field strengths.